So yeah, my name's Dan Selman. I started working for iLog in 2003 on iLog JRules, which has now become IBM ODM, Operational Decision Manager. And for the last 3 years, I've been building a new product where we've taken a lot of the technology from ODM and we apply it to real-time event streams. So I'm going to talk a little bit about that. I'm not really touching on DMN, but I will talk about kind of our point of view on decision management and decision making in general, and some of the things that we see in the industry. Feel free to interrupt, ask questions, disagree with me. That's the reason that we're here, right? Is to exchange information, not just pontificate. I won't spend. You're all technical. We don't need to have too many marketing slides. But IBM is obviously going through a big transformation. We're going from a company that primarily sold middleware to a company that's now cognitive and cloud. So that we're living that transformation that a lot of our customers are also living. The world is changing very, very fast. And that, mobile, IoT, cloud, blockchain, all of these things are arriving basically in a fairly short space of time, and can all disrupt how our customers do business. I'll skip that one. Let's talk about decision automation. So when we were iLog building JRules and when we became ODM, we mostly focused on these transactional decisions, which is what we've been talking about with DMN, right? The stateless stuff. Give it some data, turn the crank, you get back a result. It's all very nice and simple. It's easy to scale, relatively easy to understand. And it's been incredibly successful, right? We can apply it to loan underwriting, credit decisioning. Any number of industries can benefit from this kind of technology. Anyone that wants to externalize decision logic from code can make use of this technology. But what we saw sort of starting 2-3 years ago was there was another need, which is what we kind of call situational decisions, which are not stateless, and people were struggling to make those kinds of decisions. And what we did was we took our stateless capability and we augmented it with a new runtime that can do stateful situation detection. And that's what we call ODM Advanced these days. And I'm not doing a product pitch, but I kind of have to set up the context for why we think this is important.
Everybody else will.
I know how much you love product pitches.
Oh, I love it. It's not my thing.
So, why are these things different? On the left, we've got the traditional transactional stuff, the stuff we've been doing for 10 plus years. So they're usually invoked in the context of a business process or an application. Somebody needs to make a decision, right? We can't really do anything. The application can't do anything until it gets the result of that decision. It's often used and applied to data from existing systems of record, right? Someone's on your website and they're applying for a loan, and you've got to give them a price, right? Pretty straightforward. It's usually, we recommend that it's stateless, just because it makes it so much easier to test and scale and distribute. But it could be either interactive, i.e. the website, OLTP, or it could be batch. If you're processing 6 months of transactions through this decision service, figuring out, okay, what was the average price that we offered. On the flip side, the situational stuff is usually multi-channel. It's usually event-driven. It uses history. So there's a notion of, what in the old days we called working memory, right? This is very working memory intensive. Because to detect these situations, you need context, you need state. And the goal is to detect an interesting situation as soon as possible, right? While you're still in the business moment. So the customer's done this, and they haven't done this other thing. That's the call to action. We need to detect that immediately. And we can't run a traditional batch job every 24 hours to detect that situation. We've got to do it quite quickly. So you can see that the use cases are really different. So on the left, should this loan be approved? What is the appropriate discount rate that we should offer? What are the restrictions that apply to this sale? What are the documents required by the regulation? And on the right, when a customer enters the store, if they've made more than 5 purchases in the last 6 months, send a discount. When a customer logs into their account from their mobile app, if they have a higher churn propensity score, offer them 3 months of service. Or slightly more contentiously, is this transaction fraudulent given the recent history and geolocation of the customer?
Call the police.
Sorry?
And call the police.
Yeah, it could be some sort of call to action. You can see that these guys are interesting. They either break down into opportunities or threats. Okay, so some of them are opportunities in that customers done something interesting and you can potentially try to sell them something based on their context. Or they've done something which is a threat to your business and you're trying to usually stop them from doing it. So it's about, this form of decision making is heavily event driven. And when I talk to customers, I tend to use situation detection versus decision making. Because the problem that you're trying to do is, are we in this situation for this customer, or for this train, or for this airline, or whatever it is that your context is built around. And then once you know that you're in that situation, then you might need to make a bunch of downstream decisions about how you react to it. Right? So we're trying to find patterns continuously over an event stream and correlate those events with entities. So it's not enough to know that Dan made a cash withdrawal last night at the airport in terms of an event. We need to know quite a lot about Dan to figure out if that event is interesting. Where does he live? What's his home address? There's all this other information that we have to bring into the decision making. So that's what differentiates it from kind of pure stream processing, in that the context that we build brings in entity information that's not carried on the events. So airlines are great examples, right? Because they're very dynamic, very event-based. The airline decides that a given flight is going to land at a different gate, and they need to notify all the passengers. So there are a lot of environments like that that are very event-rich and very dynamic. It also exists in financial services, right? As you interact with the website or you go into your bank, you have various interactions with the bank across different channels. Some of those are situations that could be risks or opportunities that the bank wants to take advantage of. So if we get slightly more technical now, the general pattern looks like this, right? If you zoom out 50,000 foot level, we've got a bunch of event sources across different channels usually, and we need to consume those events, detect situations, and then decide what we want to do about it. And once we've decided what we want to do about it, typically we put a message back on some sort of ESP to trigger an action. Right? So, Dan did a cash withdrawal in London, 24 hours ago, and then 12 hours ago he did a cash withdrawal in New York. Is that an interesting situation? That's probably not fraud because there was 12 hours between those two cash withdrawals. So it's possible to travel from London to New York in that time period. And actually we know Dan travels a lot, right? We know he has a high propensity to travel because that's what our machine learning models are telling us. So for Dan, that's kind of business as usual. We don't need to do anything. If the time period between those two events was, say, 3 hours, then it's definitely an interesting situation because someone's probably cloned Dan's credit card. If the time period was 12 hours and say it was my wife, that might be an interesting situation because she doesn't travel that much. Right? And the bank can know that through machine learning or analyzing the data they have. So, mapping that onto IBM technology, that's essentially what our product does, right? Consume the events, detect situations, and then decide what to do. And you do that using rules rather than writing, huge amounts of procedural code or stream processing code or continuous query language code or whatever the technology might be. So we ingest events from different sources, which is kind of the sensing part of the problem. If you use this kind of body analogy, we build context around entities. So different events may be correlated with different entities. So when I make a cash withdrawal, it's correlated with me as a customer, with my credit card as an entity, and with my account as an entity. So a single event might create 3 different contexts, and we'll be looking for situations across all those contexts. Then we, once we've spotted a situation, decide what to do, and then we need to act quickly and consistently. So our design center is kind of 100 milliseconds. So we detect the situation and react. So it's not, it's not like an algo trading platform or something like that. It's kind of human real time. While you're still in the airport or you're still in front of the ATM, there's an opportunity to interact with it. I'll skip that. And then, this notion of context is key. So, as I said, we need information about the entity itself, right? Who is Dan? Where does he live? How old is he? What's his churn score? A score may be calculated by a predictive model. We might need to know information about his location in space, as well as time. The fact that these 2 events occurred related to Dan, and they both occurred within 100 miles of each other, might be interesting. Or the fact that we're having this meeting, right? A meeting is a collection of people correlated in space and time. And that's quite common in these situations, right? A situation might be that I'm in this building, or a situation might be that this thing happened close to this other thing in time. But often it's we need to correlate across both space and time. So knowledge of space is built into the rule language. So we can say things like, is the customer driving towards the airport or driving away from the airport? Is the customer in the airport? Is the customer accelerating towards the airport? All of these things make the rule language extremely powerful.
Then,
Yep.
you're going through all this data, that looks really cool, but do you have a customer who's actually doing this, or are you preparing your customer who will be doing this?
No, it was
You have a
released.
client who's doing
Yes.
this,
Yeah. We have it.
tracking the people going through the airport.
Mhm.
It's cool.
Yeah. And obviously not just airports, right? It's general technology. But logistics and airports happen to be an environment where you find a lot of these use cases that are very event rich.
I know Homeland Security does that, but they have a reason.
Yes, and we do talk to some of those people.
Then it means that the geospatial constructs available in DM as a domain specific is, and the time constructs also
Yes.
available.
Yes.
So what used to be in a CMP engine, now it's part of.
Yeah.
What DM is our special.
It's all unified. Yeah.
So you provide not like majority of vendors provide generic tools without domain specific things. People get them. It's part of ODM, everybody can get this.
Well, yes, if you buy ODM Advanced, then the rule language understands space and time in a very kind
Is
of way.
it some standard you're using, or is it anything public? For example, you want to reproduce something like you do, is it possible? Or is it?
The documentation, I can point you to get a grammar for what we did, for example. Right. So, at the highest level, what we help our customers do is to take the results of machine learning and data science, streams of events, business policy, and data in their systems of record, and fuse all of that stuff to kind of make a smart decision. So that within a single rule, I can say something like, if Dan has made 2 cash withdrawals in the last 24 hours, and he has a high propensity to churn, and he's over 40 and he lives in the UK, then what's our policy? Do we care? Do we not care? Should we let him leave? Should we send him an offer? But you can essentially bring all of those dimensions together in a very concise rule that allows you to make those smart decisions. How are we doing for time? We're okay?
Daniel,
Yep.
for your algorithms, detection algorithms, are you using machine learning detection algorithms? Or I guess my question would be, how swappable are those? Because they're different algorithms that are applicable depending on the type of event you want to characterize. Bayesian.
No, in the product we don't. So obviously there are other IBM products that do the machine learning. And we're just invoking those machine learning models as functions. So someone will have used SPSS to build that customer churn predictive model, and it will need sort of 3 or 4 input fields, and load it into the model and get back the result. But that's sort of outside
So you're using the outcome of the result of the detection. The pattern was detected. That was it. Okay.
Yeah. And that's
The separation of concerns, sort of.
yeah, customers kind of like that because usually they want to interpret the results of the model. Right? It allows them to write some policy which says, if the predictive model tells us there's more than a 70% chance of X, then, well, what should we do? Well, the right response to that predictive model probably depends on a bunch of other factors that are not taken into account by the predictive model. So kind of wrapping them and operationalizing them.
This is part that's intriguing. On events, it says detects patterns in events over time. What tools are those IBM tools that you're using at that point? I don't see or something like that determines these things happen over time and therefore blah, blah, blah.
No, well, you're writing patterns using rules at that point. You're writing a statement which says something like, if Dan has withdrawn more than $500 from
Okay, so you're
ATMs.
using historical data to detect the events to correlate them.
So you might use data science to figure out what are the interesting patterns. But once you've done that analysis, that kind of human activity, you'll operationalize those patterns by writing rules.
Okay.
So in the context of, say, Internet of Things, where you're probably talking about sensors, is this still applicable? Because you don't have time to write rules.
Yeah. In many cases, yeah. For example, in security, right? You're going to be badging in and out of the building. You may have cameras that are doing face detection as you walk around the building. Those are all events that you're going to want to correlate over space and time. And someone's going to write some policy, right, which says, if Dan enters the building after 8 p.m. and they access zone 4, then notify administrator X. So people want to write those policy statements as kind of if-then-else conditions. It's not always the case. There are other scenarios where you might prefer to use machine learning, but there are a lot of policy-driven cases.
So you're really not doing a person of interest. Person of interest is a TV show that has the machine that watches everyone. Nobody watches Person of Interest? No?
Yeah.
Okay, we got one other guy. Okay. One of the intrigues me is the guys come up with a machine that watches everyone in New York City, knows what everyone is doing. Now they have this ultimate machine that watches everybody in the world, knows what everybody in the world is doing. At all times.
We're not there yet.
Thanks, Boyd.
But it's a good segue, right? Because the challenge with doing this stuff is scale. You know, if you're watching 100 people, it's pretty straightforward. One is, you know, a big Chinese bank might have 200 million accounts, and all of those people are using their credit cards, and you're trying to detect interesting patterns in that huge event stream. So unfortunately for us, that means you have to build this distributed architecture where you've spread those contexts out across a grid of machines, and you're routing events to contexts running on separate machines, which is essentially what we do. And because you're processing hundreds or thousands of events per second, you don't have time to do a database query every time you receive an event. So you have to store a lot of that context in memory to meet this 100 milliseconds SLA. So typically, there's some sort of event bus. The events are being sent into the system either via HTTP or JMS. And when we spot an interesting situation, we put an event back on the bus so that some external actuator can trigger an action. And then, you know, we can have SPSS kind of hanging off the side here to run those predictive models. The programming model is very straightforward. It's kind of an actor-based system, you know, in computer science terms. So you model events. Events are correlated with entities, and you package up business logic into, you know, what we call agents. So agents subscribe to events, and they're kind of responsible for entities. So you know, you might model a cash withdrawal event, which is related to a customer, and then you've got a customer agent that's just sitting there monitoring all your customers. And if they do, you know, this followed by this, then you're in an interesting situation, and an agent will emit an event. And therefore, you can build these, you know, quite sophisticated kind of hierarchies of event subscription and emission. So if we look at that step by step, an event occurs out in the real world. It's related to one or more entities. So, you know, Dan withdraws some cash in the airport at JFK. That event is related to Dan. And we know that we've got an agent, some business logic that's interested in cash withdrawals. But before the agent can run, we need to retrieve everything we know about Dan, and we need to retrieve all the event history that we're keeping for Dan. Once we've done that, we can run the agent. And the side effects of the agent are strictly two things. The agent can update the state of the entity or emit an event. And if the agent emits an event, we basically go around this loop. Right? So that it's a very nice, clean model in that multiple people can develop agents, and they can do it essentially autonomously. And one person's agent can emit events that are consumed by another person. So you get this nice kind of semantic pyramid of event processing. And we've got three different types of agents in the platform: rule-based agents, predictive agents, and Java-based agents. So if you're a programmer, you can kind of play in this world as well. It's a completely top-down environment in terms of modeling. So there's a dedicated domain-specific language for defining the models. So a transaction is a business event. A customer notification is a business event, etc. A customer is a business entity. A customer has some attributes. You can build complex graphs of data structures using this modeling language. And they're automatically executable. Right? You don't need to write any Java code or XML schemas or anything like that.
You have any special name or abbreviation?
Sorry?
Any abbreviation for this language?
It's, you know ILOG, right? It's called the Business Definition Language. Okay, so it's our top-down modeling language.
It used to be business action language. Wow. Now.
Well, that's for the rules. This is for the models. This is a domain-specific language for defining models.
And it looks a lot like Java. I love it. I like it.
People can get a little shocked because, particularly if they're coming from a UML background, they expect to see boxes and arrows and relationships. What's cool about this language is, well, A, it's text, so it's extremely productive once you get to know the syntax. And B, it's text, right? We can diff it, merge it, print it, email it, send it via Snapchat. It's really cool to be able to share models with people like this.
And Gary, I like the fact you've got spaces in your variable names.
Yeah.
And you're running it too.
That's a good. Here you're defining both a model and a verbalization, right? What we call the verbalization of the model in a single syntax. So it makes for an extremely interactive kind of experience.
If he's doing the demo, I guess the drop down is really neat the way it works. I told you last night they really did some stuff about it.
I know, you said you don't love me anymore now, you're in the, you love IBM instead.
All right, people. Yeah. So this is the BAL++, right? This is the raw language that you use to express those patterns. So it's got new constructs like when, obviously an event-driven kind of a rule. So when a transaction occurs, where the location is not the home country of the owner of the credit card, definitions. So we're going to build a dynamic collection of events from working memory. Set out-of-country transactions to all transactions where the location is not the home country of the owner of the credit card. If the propensity to travel of the owner of the credit card is less than 0.25, so this is an implicit call to a predictive model. And there are more than 2 transactions in out-of-country transactions during the last period of 2 days. And the average amount of out-of-country transactions is more than 500, then we emit a new fraud alert.
Just a quick question. Add transactions, this is a user concept, it's not your thing.
Correct, yeah.
How it's related semantically with all transactions?
So this is a dynamic collection from working memory, where we're collecting all transaction instances from working memory that pass this filter.
But all transactions, it's also user concept.
No. So the word all is part of the grammar.
Because transactions, how this is.
Yeah,
What if I call transaction transact? Is it still good work or is
So when you use the all keyword, it knows that you're looking for many instances.
And so S at the end is essential.
Yes, it's added for you, right? You would have to have the S, or this would not be syntactically bound.
True sweater.
If I press Control Space in this rule, the completion would be all. As soon as I type all, it would be all transactions.
When also is keyword.
Sorry, what?
When transaction.
Yes.
And
Yes,
keyword.
this is an element of the grammar, yeah.
Well, I wish you showed a demo, because you just hit the key, when you hit the space bar, it gives you a selection to say all or A or one or this.
It's clear.
Okay, it's really nice.
So you can see
It's kind of
that
confusing when you see
this single rule has taken information from the event history, so all transactions related to this person. Information from the current event that we've just received. Information from a predictive model that was related to the owner of the credit card. And we're doing aggregations, very sophisticated aggregations across some of those collections. So the average amount is built in. And then if all of those conditions are true, then we're going to emit this fraud alert. And that fraud alert can go out to an external system that might block the account or create a case in a case management system, kick off a workflow. Or it might go to another agent, which is going to say, how many fraud alerts have we had for this customer in a certain time period? and you might be counting those 4 words for totally different purpose.
So when you put single quotes around your variables with spaces, did the business users find that unfriendly?
It's a question. They ask, when do I need the single quotes again? It's like, the rule is if you have a variable name with spaces, you need to put quotes around it. If there are no spaces in it, you don't need the quotes. So it is a little funky.
What if apostrophe is inside name?
You can't. You can't. No apostrophes in the names. What's interesting about these patterns, I think, is that they are much more technical. They're harder to create. Because they're stateful, right? And they're correlating across space and time. So the skill set to write these kinds of patterns is not the same skill set as someone who's pricing order items statelessly. So that's a challenge.
What kind of semantic validation is being built? Or does it just the model need to be smart enough not to make those errors?
Obviously there's syntactic validation. You can't write a rule that we can't execute. So it basically stops there. There's very little automatic checking that these time expressions are not overlapping. All that's still to do. But there's a very rich suite of tools for testing these patterns, because writing them's hard, testing them's even harder. You need to build up sequences of events, and you're looking for interesting sequences. So there's a testing language that understands sequencing. One more minute, okay.
You mentioned agents, or there's predominantly reactive agents, rather, or do you have hierarchies where there's more autonomous type of actions or plans and so forth in the traditional sense of it?
The agents, they subscribe to events. They can update the state of their bound entity, so a single entity that they're responsible for, or emit events. The only other thing that they can do, which is kind of critical for some use cases, is that they can schedule callbacks. So when an agent needs to detect a missing event, so the example I use a lot, right, is Dan has ordered a new credit card, and we've sent it to him, but he hasn't activated that card for 7 days. That's an important situation, right? We should probably cancel that card because it's gone missing somewhere. So you can write rules that instead of saying when a transaction occurs, you can say when a transaction has occurred 7 days ago, which creates kind of an implicit callback and allows you to say, if something hasn't happened within a given time period, what's the action that I want to take?
How's the scale of these agents? Is that an agent? Is that one rule with an agent? What sort of amount of logic is there in an agent?
So this is one rule within an agent. What we typically see is that most agents don't have that many rules, because an agent is usually detecting patterns, situations of interest related to an entity. So it's probably 10, 12, 15 rules per agent is what we tend to see, which again is really different to loan origination, where you might have 30,000 of the darn things to process a loan request. Because at least for the initial projects, there's probably 10 or 15 situations about a customer or a flight or a bag that you want to detect. But it's not 10,000 situations.
Is there any structure inside the agent sort of model, or is it just a set of rules with user patterns?
At the moment, it's essentially a set of rules. Rule flow doesn't really apply in this world because everything is event-driven and time-based. So there's no obvious way of sequencing the rules. But it's something we're mulling over.
Is this new file put back into working memory and can trigger another rule, or is that just not in this rule, but that's a possibility? Is it meant like the assert in production rule?
Well, not really. it's the agent saying, I want to publish this new event to the outside world. And the agent itself doesn't know who subscribed to that event.
Doesn't care.
It doesn't care. It could
Right.
subscribe to it if it wanted to receive it,
Sure.
in which case it would end up in working memory. But that's not typically a good idea because it's a great way to create these recursive kind of problems.
Right, and it seems like, again, Alan's mentioning whatever happened to CEP, right, but.
This is CEP on steroids.
This is CEP, like, in sort of a production rule.
Yes. Yeah. And the big problem we had with CEP was it ignored the entity part. Whereas almost all the almost all the interesting business situations require information about the entity. So the real value comes in when you can correlate events with entities and you understand both. And you build context around entities.
Is there any standardization efforts around any of these things?
I think there's very preliminary discussions. There's some YouTube stuff from IBM on they call it the event model. So people are starting to think about, well, how is this different from the decision model? Is there some way we could come up with a notation for describing these patterns?
Haven't TIPCO been using this for many years, actually, with using media and events next together?
Yeah, TIPCO is in this space, but so are others. I think what's slightly different here is, as I said, is the emphasis on entities and events together. Whereas, the stream processing products, Apama and Streambase and those guys, were very much CEP products, or the Oracle CQL product.
Yeah, there's a lot of people that know CQL, huh?
Yeah.
You think SQL is fun.
Yeah.
I have to, sorry.
So
Why you packing up? This very interesting presentation. We will have panel later, so you can ask all questions. But as usual, IBM is leading us in very interesting direction, I would say. And now it's you still can ask questions, but Charles, it's your turn.
Any questions while Charles?
While you're packing up, in 2009, I read a blog saying CP in the industry, this shouldn't have happened, because I reminded people that before CP existed, you guys had the event manager and stuff,
Yep.
and then your manager decided, oh, that stuff isn't interesting, we're just going to do decision tables. And then obviously, then it became its own industry. But if you guys had continued that, it would have just been another rule feature instead of a separate industry.
Yeah, and that's sort of where we've ended up.
Yeah.
So we used to have event features for working memory, back in JRules 3 or whatever. But the problem was the working memory was completely non-HA. Right? So if you lost the working memory, you've lost all your context. And for IBM customers, that's just not an option. So most of the engineering work was to make the working memory distributed in HA.
Thank you.